I'll just start. All day I see people coming in and out, so probably it will be the same here. But my time is quite vulnerable because I have like 60 slides, so I have to be a bit in a rush, I think. I'm going to talk to you about the continuous culture. This is about, amongst others, continuous delivery, but then it's more at enterprise level because continuous delivery is not the end point for me. I think it's beyond continuous delivery. Am I clearly, can you all hear me clearly? Because I can't, okay, great, thanks. Well, first about me. At the moment, I'm head of software development at ANVA. ANVA is a software development company which makes software for the insurance industry, for insurance companies, insurance brokers, financial advisors, so the full chain. And before I was head of IT at Klaverblad, which is an insurance company, mid-sized in Holland also. And before that, I have a business background, so it's like yucky. I wasn't always in IT, so I'm sorry. But I think it makes me somewhat richer because I can actually understand the problems they are coping with, right? But I don't ever want to go back because I think in IT is where all the fun is happening, right? So I'm having most of the fun all day. And I've been managing since 2005, and there are some Twitter handles and stuff like that. I'm also writing a book together with Sander Hoogendoorn, who was talking about monads in the Alpha room. It's also about this topic, the continuous culture. I keep saying it's due in about 3 months, but I started saying that about half a year ago. So I'm not sure. I think it will be a continuous process or something. So first about ANVA. This is the company I currently work at. And we have kind of a problem because we have about 50 developers, and we have 25 languages. So that's half a language per developer. So that's kind of a problem. And there's a lot of COBOL, like 10 million lines of COBOL. And for this application, we are able to measure bugs per hour. So that's not a good point to be at, right? If you're measuring bugs per hour at a small-sized company, that's not a good thing. But there's a lot of upsides because we are intensively changing the way we're doing things. There are 2 developers over here from the team, so I think I'm very proud to have them here because it shows we are adopting a learning organization. So this is also what it's about the enterprise level. And we are working on a fully new software solution, so we can overcome the problems with all these languages, where we have a microservice architecture. We can build very fast in small particles, and we're on our way. We have a lot of things pushed out into production already, and we're on our way for half a year, so I think we'll manage to go there. Well, because that's what it's about. It's about going faster. If you have 10 million lines of code, you can never go fast, right? If you have so many bugs that more than half your team is working on working away those bugs, then you can never go fast. And the difference is extremely big. I was really shocked at this report. This report comes from Puppet Labs, which is a serious partner out there. And they have conducted research amongst thousands of companies. And it shows that there's a 2,555 times increase between high performers and normal performers. I was really stunned by that figure. So you can go about 2,000 times faster if you're able to get to this high-performing culture. So there's a lot to gain, right? And maybe you think, well, I'm going fast enough. But if your competitors are going faster, then you still have a problem. This is what we're facing. This is the Dutch fintech landscape. These are just the traditional companies. They just put out a mill over there. And these are all the new companies. All the startups knocking at the door, trying to get an existence in a new world. And I think all the industries are like these. We have a lot of people starting up with new ideas and being able to go very, very fast. So as a traditional company, you have to make the switch. Otherwise, you'll just end up being out of business. And that's what we've seen. There's, at this moment, if you measure the average amount of time a company is in business in the Standard & Poor index, there's a drop of 75% of time of existence. So it used to be that companies existed for 100 years, But right now, it's only 25. There are people knocking at the door every time. So this is about how do you become fast enough to stay ahead of competition. And this is quite a nice introduction for it. This is the Kinetic framework. And the Kinetic framework tells you something about how do you approach problems. Are we already familiar with this framework? Okay, that's good. That's quite a few. I think it's one of the most important notions in software development because it tells you something about the relationship between a cause and an effect. So there's the simple quadrant, and it says there's a cause and there's an effect, and you can see them directly related. So it's very obvious for anyone to see the relation. It's like when I'm hungry and I eat, the hunger goes away. You don't have to be trained. Anybody can solve problems in this quadrant. Then there's the complicated quadrant. And that's where you have a cause and there's an effect, but there's a bunch of parameters between it. And these parameters are so complicated that you need to be an expert. You need to be trained, you need to be educated. And this is where we think software development is. So we get this analyst, and he does something in 200 pages, right? And at the end, we think we can solve the problem. We can program it and have it out in production, and we have a yippee solution. But it's not like this. We've seen a lot of evidence that we are not in that quadrant. We are in the complex zone. And in the complex zone, we know there is a cause and there is an effect, but we don't know enough to understand the parameters between them. We just know they have some way of coexisting, but we don't know how. And there's a way to go about problems in this zone. You have to probe. So you have to experiment. You have to use prototyping. And you have to keep learning and learning and learning as fast as you can to discover the relation between cause and effect. So if we understand that software development is in this zone, then we have to get really good at experimenting, right? Because this is the way to go about it. Then there is also the chaotic quadrant. Simply it says don't go there because it's dangerous, it will cost you a lot of money, because there is a cause and there's an effect, and we don't know if they're even related to each other. And we don't know even how to start at finding out how they are related. We don't know what experiments to conduct. So sometimes you do have to go there because you think, well, if we're able to do something over here, there's a lot to gain because there's no one else in that zone. Everybody keeps away. I should have made it red like Kevlin did, like this is danger. But if you do want to go here, then you should just act. Take a first step. Try to learn something. That's the way to go about it in that zone. So how do we, if we're in a complex zone, we have to do experiments. This is what this culture is about, how to do experiments very rapidly. And how does this work? Well, if you look at, we have risk, which is accumulating as we're extending our moment of delivering value. This is traditional waterfall, right? There's this one moment we go into production, if we ever get there, but let's assume we are. And all this time, there's a lot of risk accumulating. While if you are able to deliver incrementally, then there's just this little bump. And from that point, you can add value every time, and your risk will remain the same. The amount of resources that's in your project will be around the same. So that's the first value there's to gain from experiments, and this is what I call the value of delivery. When it's out there, there are people actually paying for it because they can use it, right? But there's another benefit. Oh, sorry. This one's first. This is a number that really proves it quite right. This is from the Chaos Manifesto from the Standish group. It says that small projects succeed for 76%, while large projects only succeed for 10%. So that's almost an 8x increase. That's really a lot. That's your first step towards those 2,000 times increase, right? There's a next step, and that's what I call feedback value. Because at this point where you were starting, you had a lot of assumptions. And you have to test your assumptions, because mostly we're wrong. And it means that not only there's value from delivering things fast, but there's also value from being able to respond to the feedback you're getting. So there's data-driven decision making. And this feedback value is the value of building the right product, and also the value of early elimination of the wrong one. because you also have to stop doing the things where you were misassuming. Because otherwise you will go to maintenance hell, right? You build something and there are some people using it, but it's not really worth a lot and you'll never make money on it. It's one of those activities you're really losing a lot of money on. This is the one graph that quite nicely shows it, where this is the period before Agile. There was this measurement and it said that 45% of features is never used in production. This is a research from 2009. And another 19% is rarely used. This is less than once per year. So 64% of features is never used. If you imagine if you can eliminate those features from your system, how much easier your life would be. It would be more than 3 times easier, right? Because you can eliminate a lot of complexity, because you get a lot more dependencies from having this much features. So there's a lot to gain there. And if we look at post-Agile, where we get better at these things, and I think we can get a lot better, even from where we are now. But you can see over here that there's just 14% of features that's never or rarely used. So that's also a tremendous improvement. And it diminishes complexity by a lot. And this is what it works like. It's most of the times we think of innovation, we think it's like an epiphany. There's this moment and we understand the world. Like the Matrix, we saw the green things running there. But it's not like this. We have to try and try and try again, right? So, for instance, Thomas Edison took 10,000 times before he could invent the light bulb. It's not just something he thought of overnight. It's hard work. And this is the way to do it. You experiment, you put it out there, you try it, and if it doesn't work, you eliminate it. And then there's another value, and this is what I call flow value. And the flow value is about eliminating a lot of activities that are bound to having these big projects. Like estimating, how long will things take? There's a lot of meetings, we've all been there, right? Where we have to address points to stories and we have to have an impact. And if you're able to go to a continuous flow of things just going through at a certain amount of time, then you can eliminate a lot of those overhead meetings. So the flow value is the value of reducing overhead of estimation, of refinements, of reporting and of meetings. Because there's so much risk accumulating. There are a lot of people who are trying to control it. And you can really do without. This is what we are finding out. And I think we can still grow. It's more like this, right? When you go into a shopping store, into a mall, you can choose a line. And sometimes we choose wrong. We think this one is the fastest. And then we try to switch. And then the one you switch to is then the slowest. You know this problem. But we're good enough at estimating. You can understand flow. You can understand this is quite a big shopping cart. So this lady will be quite slow. And this is really a small shopping cart, so it will be fast. And we don't need any estimation for it. Because all the shopping carts are about the same size. And because you have a continuous flow. So we don't go sitting with all the customers in the line and do an impact analysis or some shopping cart point story estimation or something. We just choose a line and we sense how long it's going to take as a customer. This is also how we can work with customers. So how do we deliver incremental change? This is the main question, right? And I've learned a lot of lessons along the way because I've experienced doing this at 2 companies. I threw this talk around because first I started with this big theoretical concept and I thought, well, it's a lot to take and maybe it's much easier to start with the lessons I've learned. So this is also new for me. I'm going to try. I hope you like it. This is lesson number 1. You have to be able to safely and sustainably deliver a software to enable experiments. In other ways, you have to have continuous delivery. So what is continuous delivery? Continuous delivery is a set of practices and principles in software engineering aimed at building, testing and releasing software faster and more frequently. So that's what it's about, to deliver fast and frequent. And for me, the main lines are, you have to be able to reduce time and costs and risk that's normally associated with delivery. so to able to deliver ultimately small changes and ultimately value by allowing for incremental changes. So you have to allow those little changes to accumulate. And what is continuous? That's the main question, because we're really bad at naming, and continuous is something that can be done for delivery, right? There will always be a little pause, so it will never be continuous. But what is continuous? Well, for most enterprises, we're over here, releasing somewhere every quarter. Is there anyone here still releasing quarterly? Or less frequent? Okay, yeah, that's good.
I'm probably the only one working at bank.
Yeah, I know, I was in an insurance company, so we started out here. We had this quarterly release, and it's not something to be ashamed of. I mean, it's quite hard if you don't have any test automation to be more frequent than this. It will already ask you a lot of effort, right? So, but what we see is a lot of companies moving forward to releasing each day. Who's already releasing each day? Okay, so there's a lot of people in between. So there's two over here, and a bunch of you is over here, right? Okay. Well, I think that's quite states where we are with continuous delivery right now. I mean, not everybody's talking about it, everybody's going there, but we aren't quite there yet, right? Because we have some problems going there. Well, we went from here to here for some of our applications at least. At Klaverblad, we went to here for our new applications. At ANVA, it's the same, actually. And also 2 legacy applications went there, right, to a daily release. And Etsy is over here. They can release 10 times a day or even more frequent. But it can be even more. Do you know what the delivery record is? Anyone, any idea? Except for Sander, because he heard this talk like 100 times. So what do you think? 100 times per day? Or more? Who thinks more? Yeah. Once per minute. Ah, that's fast. It's once every 11 seconds. So it's 7,448 times in one day. Obviously, it's Amazon, because they really invested in this, right? So that's once every 11.2 seconds, to be exact. And that's quite continuous. I think you can call that continuous. They might. So we thought, well, it sounds nice to be able to deliver risk-free and to reduce costs. So we thought, well, let's go there. We did with Klaverblad, and we had no clue what we were doing. So we said, well, okay, we're starting, we see some tools, we started adopting those tools. We had no requirements revision because we didn't know what we were doing, because it was somewhere in 2014 or something. We thought, well, we have all these primary projects and the teams can add this activity next to their primary projects and just fool around with it and it'll probably be fine. Well, it wasn't fine. The results were we had incomplete tests. For instance, we had this component and we had 10,000 test cases running on this component, and we went into production daily on this component. So we were very proud of ourselves. We thought, well, we have it running, right? But the test was directing to a wrong location. So we were going into production for half a year with an empty test set. And that's bad. It was on live premiums, so not the part you want untested out there. Somehow we ran the test and they were all green. We don't know how the miracle happened. We were very lucky. And we had no choice in shipping. So once a feature was going through the build pipeline, it had to go to production. There was no choice for the customer to say, well, I want this feature, but I don't want that one just now. So things just had to proceed. It was also a difficult problem because we weren't ready to ship all the projects we were developing. We had no monitoring. So at some point, we just had this very small database with 8 gigs of storage. And somehow it just grew out of it and the system crashed and we didn't see it coming. That's also really bad. Because nobody found monitoring any fun. People just took a subject and they found it fun. And nobody chose monitoring. And we weren't managing it. So that's what happened if you just let it all loose. And nobody, of course, was interested in compliance or control because that's even more boring than monitoring. So nobody was working on that problem, right? So that was the first real lesson for me, because the first one was just obvious. Continuous delivery means you're building software. So treat it as a software development process, because it is. And what have we learned from making software? We have to do it agile. We need an MVP. We need a backlog. And somehow, when we started with continuous delivery, we forgot all those lessons. And without any planning or without any requirements, we just started. And that's strange, so never do that. So we changed things around when we found out we were making a mess of it. And we did have this backlog. And there were a lot of stories, and we prioritized them neatly. And someone was working on the monitoring problem, and someone else was working on the compliance problem. So it was fixed quite fast. And I also found this one. This is a maturity model on continuous delivery, and helps you prioritize. If you Google maturity model and continuous delivery, you will find maybe 20 out there. I like this one personally from Xebia. And it tells you, okay, first make sure you're at level 1, because these subjects interact with each other. And if you use some kind of a model where you let this one grow over here, and you have this one way down here, then it's not consistent with each other. And the risk is bigger than when you are here for all the activities. So you can use this one. I don't think you can read it, so I grew level 1 out. And it's about, if you have continuous integration, you want to move to level 1, then you have to have static code analysis, you have to have some unit testing, obviously, because you can't go untested into production. You have to have your deployment automated, so just a one-push button release, where you build your binaries once, you just push them through the build pipeline. You need agile test practices, and you need to focus on code quality. So if all your testers are saying, well, let's just do it manually, you have to discuss with them that things are changing. You also need some guidelines to allow faster delivery in your architecture. Maybe talk about moving to microservices. It's not necessary, but it's an evolutionary architecture, and it really enables you to experiment and to grow as you go. And you also need some agile practices where you need to have an agile organization to start with, because if you're not there yet, then there's no fun in building things or being able to deliver them daily, because you're building things in periods of 3 months, and being able to deliver daily doesn't help you in that situation. So this is very theoretical. I made it a bit more practical. So this is where we were. We had this developer environment. We had some test environment, integration, acceptance, and production ultimately. And what we did to get started, because we had 0 code coverage. Well, that's not true. We had 0.56% code coverage, which is also approximately 0, right? So we added an extra environment where you can still do manual testing, because you still need to manually test, as you did before. This extra environment is something you will eliminate later, but it allows you to start with continuous delivery. Because you have your build pipeline set up, and you can proceed automatically through all these phases and still have this point where you can do your regression test just like you used to. And from that point, safely go into acceptance and production. So there's no extra risk. You just have kind of a way to proceed. Because this is what you're doing next. You're adding tests and you're adding metrics. So in integration and in different test environments, you have to think how many you need. At least one for unit testing, maybe one for component testing, and maybe you need even more test phases to be able to test some critical functionality first, because otherwise your test may be running too slow and you get feedback too late. But it's very individually, because some people have little tests and they're running very, very fast, and others have such big legacy systems that you will have to make more test phases. And if you're able to do this, then for each test you add over here, or you add over here, you can eliminate a test you're executing over here. So there's a direct benefit from adding tests in your automated suite, because you can push down the time you're using to do the scenario testing over here, the manual testing. Each one that's replaced, you can eliminate from over here. Then, of course, before you go further, you add some monitoring. We use the Elk stack at both companies I worked with, which is Elasticsearch, Logstash, and Kibana. Kibana makes it graphical for you, and it's very easy to set up. We were up in a day, and it works quite fine for us because it's quite easy to implement. And also there you can prioritize. You don't have to monitor anything. Just start with a bit of information, and if you end up missing something, you just add the metric, because it's easy to set up. And you add reviews over here. Because if you push code into production every day, you want some kind of control over code quality. And there's no code review at the end. There's no review process that you're conducting when you're going to production every 3 months or something. So that has to be continuous. And developers just start talking with each other about code quality. And we used, at Cloudblood, we used UpSource. Developers found it very nice because it was running inside your IDE. So you can actually see the change in line with the other code. And it works more nice than when it's apart from it. And if you're at level 1, then you can prioritize the rest of the activities. So, and it depends on what kind of company you are. If you are really concerned about quality, you're working at a bank, so I think quality is always an issue, then maybe you want to proceed with setting up some security tests, some performance tests, maybe even some tests on the quality of your tests, which are, by instance, mutation tests, which is a technique to do this. But maybe if you're very customer-facing and the quality is less a concern because you're, for instance, a web shop, then you can maybe add more of your activities to experimenting. So, for instance, A/B testing would be very nice, where you can compare 2 versions in production and see which one works best. Because you have 2 versions and there's just a little change, and you can just measure which one works best for your customers and which one will gain the highest yield for yourself. Or you can do some canary releasing, which also allows you to experiment, because you push out a version into production to a small part of your customers, and all the others keep working on the one before the new production release. And just the new part of the customers can experiment some problems, but the impact will be much smaller, right? So you can do this process much faster. You can also try blue-green deployments, everything that supports data-driven decisions. Maybe if you're very customer-facing, you have a lot of activities on assistance, user assistance, like walkthroughs, like chatbots, distributed releasing. So maybe you don't want to push your release to customers all at once, but customers get a choice when to release. Or maybe you're very interested in health. You just have to prioritize this backlog. You also need a product owner, someone with a clear vision, what's important for your company. Okay, that pushes me to lesson number 3. You're only as small as your MVP and as agile as your roadmap. We can deliver things small, and if we use the 2 lessons, we are able to deliver daily, right? But if someone at product management thinks of a product that's just half a year of time that's needed in building, and it's not possible to make it any smaller, then there's no need in a daily production, right? Because there's nothing to gain. The problem is still half a year big. So you need to be able to be in a conversation with product management and make things smaller. So we were in this place where we had extensive planning. We had roadmaps. This is from the beginning of January, and we had roadmaps which were very detailed for a year ahead. So whatever we were learning from feedback wasn't valuable for us, because we already were working on the next activities. We were ignoring feedback because we had to move on. We already promised customers all these activities. This is also an example of it, where we promised to make this integration with Postex, which is a company we integrate with, and we promised it 8 months ago. And there was no planning on putting it into production at that time. No one had built any letter of code on it, right? So after that, whatever feedback we got from customers, whatever we were learning on the way, we couldn't use it anymore because it was already promised and announced to customers. So we tried to change things around with product management. We sat down with them. We explained how we wanted things different. This took us a lot of time, sometimes a lot of energy. It also gave me a lot of energy for the steps we did manage to make. Let's see. So what we did is we now have agile product management. We're still working on it. You have to learn a lot of lessons, but we're here, and this is an official process now. We have this portfolio board, and the portfolio board decides on ideas. Anyone can proceed an idea to a central backlog, and this is about minimizing the effort we put at things we are never going to do, or maybe never going to do. We just want to work on the things we are doing, because those are valuable activities. So we decide at a very high level, yes, this is something we want to do, then it proceeds to the team backlog. It might be something we want to do, but we want to do it later, so it goes to the parking spot for 2 months. And we don't talk about it anymore, it's just in the parking spot. Maybe it's something we say, okay, might be interesting, we need to do some research. So people don't do research up ahead, they just come up with this big plan without too much effort in it. And then when we say, okay, we see potential, then there's research address to it. So then that's where you start working on it. It might be no. And then we minimize the effort because we only talked about it once. Cost us all a minute. And it might be, well, maybe. We don't want to kill it right now. But we don't want to do anything with it in the next period. So let's put it on a parking spot for 6 months. We had to learn to do this, of course. It changes things around because they were, at product management, they were accustomed to making business cases. So we had these 20 pages business cases with a lot of effort in putting numbers on it, and they had to stop doing those things and think differently about the things they were doing, right? So we tried this one. This is from Lean. It's this product vision in 1 hour. You can fill this statement for a big new project, and you can have it ready in 1 hour. And it has enough information because it says, well, anything you can't pitch within 1 minute is a bad idea. If you have to use more words than that fits in 1 minute, then it's probably too complex. It won't make it out there in reality. And we used this one where we said, okay, how much value does it have? And how much effort does it take? And things that take very little effort and have a lot of value are the things we are doing right now. So that's what we're talking about. Quarterly, we just put on the post-its and we say, okay, these are the quick wins. We should do them immediately. These are very nice because they have a lot of value, but they also cost us a lot of effort. So we have to think which one we're going to pick up next. Over here, they cost a lot of effort and they have little value, so don't do them. And over here, they have little value and they cost little effort. So it might be something you should do. And this is very intuitive. It really supports the discussion with product management nicely. And they are actually thinking in smaller particles right now. And it makes us more agile and makes us able to react, to respond to things we see happening. But they are not the only one who are changing. So software development is changing, product management is changing, but there are a lot of other people who are also changing. For instance, auditing and compliance is really changing. They were having tests like security tests. So when you go to production, especially in a regulated industry, you probably have this penetration test before you go to production. But we can't do that because we can't do a penetration test every 11.2 seconds. It would be too often. So it has to be something that runs within the build pipeline. So we sat down with the auditors. We said, okay, we have a problem. We are an insurance company and want to go to production multiple times a day. How can we do this? And it was one of the best and easiest conversations I had with external accountants because they were very cooperative and they said, well, we actually really like this idea. And I was stunned because I didn't expect that answer. They said, well, before we had this form and people were signing off, but we already knew that the people who were signing off didn't ever look in the system. So they had no clue. This was just kind of a role play, right? And I think we know this role play. People are signing off and they don't have a clue what they're signing off. And now they say, we can see that everything is in version control. So this is a kind of a safety thing. We have test change approvals. So there's this kind of defined way the system should be working. And this is your test set. And this is something you check every time you go to production. So they said, well, we really like it that only green goes to production. We have a lot more control than we used to have. And we can also make sure that every time the test changes, we can approve this process. We can enforce peer review, so we know for sure that every line of code that goes into production is seen by a second person. So there can never be malicious code into production without anyone else seeing it, right? And they have conformity by design. So we already know that there's a lot of checks that are executed, which is also known in this graph. They asked CIOs what's the main driver for cloud adoption. And the main driver at this point, by far, is the compliance requirements. Because we are able to implement a lot of compliance requirements by design in the infrastructure, at the infrastructure level. And they are unchangeable for all the others. And it gives us a lot more control over the safety of our systems. What was also changing is business IT, because there were a lot of entry patterns we had to work around. So they were used to having fallback plans. They didn't trust us. So they said, yeah, well, you always mess up, so have a fallback plan in case you have to roll back. And it was a plan of 20, 40 pages, something like that. And we can't make a plan like that if we go to production multiple times a day again. We had to also get away from manual acceptance testing because we had to speed up. And education, we can't give courses every day about the new features. User documentation is the same. We can't maintain user documentation on a daily basis. And the communication had to change around. So there was also a big process over there where it was changing. So we said, okay, we're going to look at walkthroughs, for instance. We need to educate the user as they are using the system, not externally from using the system. We also needed a feedback button. Sometimes we break things. Let's at least make it easy to report those things we are breaking because that will annoy the users less. We are now experimenting in one team with chatbots, which will also be interactive with the user in the application to make sure that they are assisted, but they are not bothered with a daily update of their manual because they can't keep track of that, right? And we're also just now experimenting, this is from last week, with an integration with JIRA. And this is just a dump of all the information from JIRA. This is just the first version. But we can make the connection. And now all we have to do is filter the information in the query. And then we can have release notes automatically pushed to our users every time a feature goes to production, because the JIRA issue is noted in the code. So we know that when it's released, the release notes will automatically be updated and the user will be notified. So you have to change your way of thinking how to interact with your users. Then the next lesson, old school HR management and functions undermine autonomy. So you have to reinvent these. This, for me, is the hardest part right now. This is quite harsh. I found this one. I found this one very inspiring. This is the Agile HR Manifesto, where they say, okay, you have an Agile Manifesto, we have an Agile HR Manifesto. So we think it helps us to collaborate over hierarchy. It helps us to be transparent, because how can you be autonomous if you don't know all the information you have to decide on? So you have to have information to be able to make the right decisions. So try to be as least secret as you can be. You have to be able to adapt over rules. You have to be able to inspire over management, because we don't like to be controlled. We like to be more energized, right? Intrinsic motivation over extrinsic awards, and ambition over obligation. These are very relevant to us. And if you sit down with your HR department, if you sit down with your management, you say, okay, this is how we want to work. How can we get there? Because they are not on this page yet. They are not on the page that they need to change. They just think the software development needs to change. So this is what it looks like. This is what managers believe that matters. So performance metrics, supervision, clear rules, competition. And if you ask employees what really matters, it's autonomy, responsibility, recognition, very important. Collaboration, mastery, and trust. And in the middle, there's a decent salary. That it actually matters, of course, but it isn't the only thing that we are worrying about. So we try to change the way we do performance reviews because we had this annual performance process and it kind of conflicted with team autonomy because the team decided they had to go this way. And if I, as a manager, were reviewing people on the old way things were done, then there's a conflict, right? Because for every employee, there's a decision to make. Am I going to do this for the team? Or am I going to do this for me as an individual because I will be reviewed on this process? And you don't want these conflicts in a team. You want team autonomy. You want them to move. So we're changing feedback around. And we call it feed forward because it's about learning. It's not about looking back and punishing. And I say to all the external stakeholders, everybody who's not in the team, okay, you can say something about the team, but only on the team level because that's what the performance is about. And then there's, for the feedback, there's a lead review, that's me. I'm also someone who coaches the people in the team. There's a peer review. This helps you to improve as a team. There's a self-review. It helps you to accept some criticism you're receiving because you think about yourself. And then there's this team level. I already had this one. And we're trying to start up with these things. So for the KPI on the team, I'm changing it to 2 measurements on tempo and 2 measurements on quality. These were advised by Jess Humble, and he knows his thing, right? And he says, in his experience, these are the best measurements to do. And it was the key takeaway of his keynote. So this one really stuck with me. And it's nice because these 2 are an incentive to deliver fast. These are incentives to make sure you're making steps in your continuous delivery process. You're speeding up. But it's not at any price, because if you're speeding up without maintaining enough quality, you'll be punished on these 2 measurements. Time to restore service, so how fast can you be when you break something to restore it in its original state, or in maybe roll forward, so how long does it take you to fix it? And also, how many times are you breaking things? So these measurements are on team level. And individually, we are just now implementing a new system where you have, there are three tools out there which are very cheap. It's like €4 per employee or something. One of them is TrueQ, the other one is Impraise. And they make feedback more fun because it's very easy. You can do it on your mobile. You can send someone a compliment, for instance, and then you have to shake your phone and then some flowers pop up. So it's kind of fun to give compliments to each other because there's some gamification over there. It helps you to give more feedback and really promotes to give more feedback because these long forms aren't working. And here you have just this one question. You can touch the amount of stars and then you're ready, and then you can head on with your work because we want to develop things. We don't want to give feedback as a job, right? Otherwise we would have been managers. And autonomy is about trusting and giving space. For instance, this is a guy who said, when we gave him some space, he said, okay, I really want to refactor some code because it's been annoying me for quite a while. And I said, well, go ahead. And he did. He spent some working time, about 2 weeks. He spent a lot of private times because he was so passionate about it, about 6 weeks. And he refactored this big pile of code, which was 60,000 lines of COBOL, into 15,000 lines of COBOL, still working. And that's what you get when you give some trust. People really get passionate about it. He didn't get any extra payment or anything. He just got the room he really wanted. And this is also funny. This is our director. And it used to be that people came to him, and he was in control because he oversees everything, right? And things really changed for him because now with team autonomy, there were all these conversations, and he didn't have any control over them. So what he did one day, he just grabbed a chair, and he thought, well, okay, if the information doesn't come to me, I'll go to the information. And he sat in the middle of the teams. So over here is where Dominic sits, right? And over here, Bram, who's over there. You put him there. Oh, that's great. It's one of the funniest pictures, right? But it really asks leaders to change. And in my experience, I found this one scary because as a manager, for me, there was a way of doing things, right? So I was also in these patterns. And like Linda said yesterday, change is hard. And now all these people are doing things, and normally I was kind of proud of the things they were doing because I had a role in it. And now they are doing all those things all by themselves. So I can't take any credit for it. So I was thinking, okay, why am I here? I will go sit in the corner over there and just do nothing or something. It really took me some time to find a new role and to be able to coach people without feeling so insecure about myself. Doesn't work every day, but it's really a change. It takes time. And learn to learn. Lesson number 6. So you have to do new stuff in coding every day, right? So, for instance, very, very new cool stuff. Here is one of the team members who's doing COBOL. It's very experimental. Was from last week. He had to learn this to do some new activities, and he didn't do COBOL before. It's just a joke, of course. But you have to do a lot of new stuff. So we invented this board. We made learning also continuous. So here's Bram, here's Dominique. I said you were in the presentation, right? So he's going to visit a congress in the Outland. It's called Build Stuff. I think you can put this in the progress column right now. But we said, okay, learning is a part of your job. So you can't have this learning event once a year and then do nothing a whole year, because there's a lot of things to learn. So every time the team encounters something they have to learn that's new for that day, then they just put it up on the board. They say, okay, we have to learn something about Kotlin. Let's put it up there because it's going to take us some time and we want to make sure that someone's working on the Kotlin thing. It really gives a way to somehow monitor what people are doing in learning, but still make it very light, very friendly, because it's very accustomed. It's just like working on issues. And together we are trying to discover and celebrate new knowledge. So we have all these knowledge events. We set up an academy, an internal academy, where we can share internally the new information we've learned. This, for instance, is a workshop that Bram did on how to implement microservices components. So he was learning all the other people how to do this. We also have this knowledge event where we're sharing information. Over here also another version of the workshop. In December we have a hackathon, also about giving trust, about giving space to learn new things, to work on the things that you want to, instead of the things that product management is saying you have to worry about. And that really changes the culture around, because people get more interested in learning, and this goes very fast, much faster than trying to change the managers and HR around. You also have to design for fast feedback and evolution, because it's not only being able to push into production every day, but you want a system that's evolving in a way that, that you don't have this big technical debt in the end. Or security incidents in the end, and that you have to do a re-architecture, because that will really slow you down, right? So you have to make sure you architect for evolution. One, obviously, is a microservices architecture. It's the first architectural style to fully embrace continuous delivery. It's made upon continuous delivery. This is from Neil Ford from ThoughtWorks. Microservices supports incremental, non-breaking change as a first principle along multiple decisions at the structural level of the application. So actually it says microservices will help you to don't think ahead 3 years, just build the thing you're building now. And if later you get a bunch of new requirements that you didn't think about at this moment because you were only thinking about tomorrow, then you just throw away this microservice or this micro application and you build a new one. Because at the moment we're building microservices in 3 days. Not in 3 weeks. So if you have to throw something away, that's not really a bad thing. It saves you a lot of thinking up ahead, a lot of meetings, and gets you a lot more fun. We also had to rethink about how we're going to test. As I said in the beginning, you have to think about your test pyramid. This is the traditional test pyramid where it says, okay, you have a lot of unit tests, you have some component tests, some integration tests, some API testing, and you have as little as possible in your GUI tests, because these are running slow. And recently I heard this talk from Seb Rose, so he gets all the credit for it, and he said, well, I don't like this category, because you should focus on value of tests. because your testing code is a lot of new code that's going to start. And testers are about quality. So if you ask testers, the nicest thing they would do, if they have the choice, is test everything. And that's not what we're doing with coding, right? With features, we're also making choices. Some things can be valuable, but they cost too much to implement. And with testing, it's the same. You still have to make choices. You can't test everything. Because at some point, right now, our testing of the legacy code base, which is automated for 60%, already takes us about a week for one test run. So we spin it up over multiple servers and we get it done in 12 hours, I believe. But still, this is kind of becoming a problem with 60% test coverage already. So you have to make choices. And he says, okay, you have a lot of tests which are small. No matter what the level is, make sure they are small and they're running very fast. And make sure you get feedback on the things that are critical for your organization. So you have a lot of tests that are critical and small, and you have littler tests for things that are less important and big. And this is how you do your testing architecture. And you have to make sure those tests are maintainable. So if you have a lot of declarative style in your tests, then you get a lot of maintenance. For instance, if the password would change in this style, this is a cucumber test, if the password would change, this is used in maybe 10,000 test cases, where you have login as a part of your test. So you would have to change 10,000 passwords into password 02 or something. Whereas if you do it in the imperative style, you say, I confirm my password of choice. And you have the definition of what your current password is in a library centralized. So if you change the password, you just change it in one spot. This is much more maintainable. But testers aren't programmers, so they didn't understand what a library was when they started, because they didn't use those things before. So you need some engineers who help the testers making code that's maintainable. Well, this was the sheet he was talking about. He saw that he overlooked it. Branching is your new mother-in-law. Sometimes you have to go there, but you want to minimize it. This is about how do you make sure you get your shipping choice. Not all customers want to have this feature into production at the same moment. And you have to think about how to make a solution about it. And this is how it works. We have all these applications, and at some point they integrate. We do some integration tests, some rehearsal, and in the end it's delivered. And there can be a problem because, for instance, if a lot of features end up over here in user acceptance, and the customer says, okay, this one I approve, and this one I approve, but these three aren't approved, then we have a big problem. Because we tested this feature with the old landscape, then came this feature, so we tested this feature in integration with this feature and the old landscape. Then this one, and this one was tested upon the existence of this one. So we don't know what happens when we push this one into production without having it tested with the old version of this feature, because that test wasn't conducted. We tried out, like, okay, maybe we can just test everything with the old and the new version. Then we had 200 components, so you have 2 to the power of 200 tests if you do this. That's impossible, that's billions of tests. So you can't test for everything, right? So you have to make choices. And what we found is what I call the shipping delay pyramid. Do a lot of time in co-creation and pre-acceptance. So if you're building a new feature and you're not sure what your customers are going to think about it, then don't wait until acceptance test for the first time to ask them. Because if it's critical, if it's maybe a little bit scary or risky, then ask them in advance in the first phase. That helps you a lot because most features will proceed to production instead of being stuck in acceptance testing. You can make sure there's no front-end path. You can push everything to production in the back end. If there's no path from the front end leading to it, then it doesn't matter, it's in production. So even though the customer doesn't approve of it in production, there's no problem because it doesn't hurt being in production if there's no front end button leading to the function being executed. Then you can do some feature toggling. You should minimize it because it leads to a lot of extra if statements in your code and you have to remove them later. So you have to do things twice. Again, testing your code. And in the end, you can go for branching. But branching ultimately is the exact opposite of continuous delivery, right? You're extending the moment you're integrating with the rest of the code. So if you take branching as your first preferred option, then you're doing the opposite of what you're going for, and that's continuous delivery. So be very careful with it. Only do it when you have this big refactoring of some central library or something. That's something you can do in a branch. There's no other way to do it. And I'm not saying don't ever go there, but minimize it. Then the next lesson, customers don't want continuous delivery. It took me a long time to understand this one. Because at first I thought, well, we as software development really want to go there. We want to deliver continuously. And there was a certain moment where it really struck me that the customers didn't want that. And what's that about? It's about legacy code and broken trust. We were having bugs per hour again. We have this big legacy code base. So when we told customers, okay, we have this new exciting plan, we're going to production every day. And we were already having a bad time doing it once every quarter. So customers were very, very restless. They thought, if you're going to production every day, and already right now I have to do 2 weeks of acceptance testing. So my users can't do anything else than acceptance testing all day. You can't go to production every day. So make sure you coach your customers on the process you're going to. What we found is if you can collaborate with users on test automation, that helps. Because they do a lot of things with the system we don't know about. So if you make your test set, and if you explain to them we're automating those test sets, then if we collaborate, we can actually test for the things they are doing with the system. It will help you eliminate bugs. Try to first improve and then accelerate. Make sure first you have your build pipeline in there. Make sure you have test code coverage, that you're pushing out to production with lesser bugs than you used to. And then start chatting with the customers like, okay, we think we can speed up from going once every quarter to once every month. But first is trust, then is the acceleration. And pull, not push. Make sure you're building so many cool new stuff in new releases that they say, okay, we want to have the new release. That's a much better position to be at. And explain what your goal is. Because I find that if you explain why you want to go to production every day and how it helps to deliver incremental change, that they are much more willing to experiment on this with us than when you're just speeding up on production. So to conclude, if we look at the continuous culture, for me, it's about continuous delivery, which will enable rapid prototyping. It's about agile product development to make sure you can do small experiments and seek value. It's about enabling learning from experiments. So you have to have this learning organization. It's about agile HR, support people to learn agility and improve their capabilities. Make sure you have autonomous teams, so empower teams to decide and adapt fast. And you have to have some evolutionary architecture. It doesn't have to be microservices, but you have to make sure it's evolutionary. And number 10, because I promised you 10 lessons, be ready for surprises, right? Because it never is as you expected. Like this one, this came a bit too late. And this is what mostly success looks like. It's not this straight line up. It will get you down, it will knock you down, and every time you have to get up and just learn something and try again, because in the end, you will reach this higher point where you were aiming at. So that's it. Thank you.